Hello, everyone, and thank you very much for giving me this opportunity. I'll speak about our solution, computer vision solution for processing and analyzing engineering drawings. In particular, piping and instrumentation diagrams, or as they call P&ID diagram. Before I demonstrate the solution, I'll just give a very brief background about the problem, the challenges, and the solution that we proposed. This is initially started as a funded project by the Data Lab Innovation Center in 2017 and the NVGL. And the aim was to provide a solution for processing and analyzing complex undigitized documents called P&IDs. These are common in the oil and gas industries and other industries, and processing these is useful for so many applications. One of the challenges, obviously, is the diagram itself, because these are legacy documents, low quality, in addition to the complexity of the shapes. But also very little research was found related to this problem, despite the significant progress in core image processing tasks in recent years due to deep learning and convolutional neural network. I mean, extensive details and description of the problems, challenges, and existing literature can be found in our review paper. So our initial approach to the problem was basically traditional machine vision approach, build some heuristics such as half transform, edge detection, etc., and then feed it into a classifier, which somehow provided a reasonable solution to the problem. I mean, we managed to process most of the diagram, and some of the results are already published in the public domain. However, we discovered that this solution won't generalize well across wide range of documents, and also it requires extensive user intervention. That's why we decided to go for another phase, and again was funded by the Oil and Gas Innovation Center and the Data Lab and our industrial partner. And here our aim was more to build an end-to-end solution with minimal user intervention and more accurate localization of the symbols and the elements in the diagram. So just quickly to show you a video, I ran this offline because it takes 5 minutes to process the engineering drawing. But once it's processed, you can have, almost all the symbols that we trained the system to detect will be recognized, and visualized numbers, text as well. If I just move, just for the sake of time, all text will be also localized and recognized using some, techniques, including, OCR-based methods and some advanced deep learning-based methods as well. Other than the text elements, you can see that also you could process a certain selected area in the diagram. So if you are only interested in one area of the diagram, you could do that. And similarly, you could search for a particular item. This also proved to be a useful and handy feature. But what's more important is you could actually export the results into CSV or other data format. And this means that, this whole diagram become readily available for further analytics for any type of applications, such as asset management or monitoring and tracking of equipment, etc. The results of this work, roughly 96% of these diagrams were accurately processed and analyzed, and we published technical details, including the results and description of the dataset, can be found on our latest publication in Neural Network. And to wrap up, I think this is one of perhaps the first end-to-end framework which aimed at processing and analyzing complex documents such as these. It proved to be fast, and it requires minimal user intervention. We are working toward generalizing this solution across other engineering diagrams. I mean, we are a team working on this project, and we hope to grow more, by recruiting more PhD students on this particular area. And for any further questions, please refer to my website. It has full list of the application, and feel free to email me as well. Thank you very much.